Let's look at page 214, number 6. This question talks about a football that was kicked, and a relation is given to express the height of the football as a function of its horizontal distance covered. The question says that h equals negative 0.1 times d minus 8.7 quantity squared plus 7.6. This is a parabola in vertex form. Normally, the letter y is here, and normally the letter x is here. But other than that, we see that we basically have, if we leave everything else the same, a parabola in vertex form. We have decimals, which we may not enjoy too much, but we already have the background that's going to enable us to answer this question. So the question says first, what is the vertex of the parabola? Well, we know that the vertex would be positive 8.7 and positive 7.6 because we always change the sign inside the bracket, but we leave the sign the same outside. So our answer to part A is our vertex is 8.7, 7.6. Question B then asks, what is the football's initial height? Well, the word initial means beginning or starting. And when it says what is the football's initial height, it wants to know how high in the air it is at the very, very start. Well, we know that at the very, very start, the d value, or in other words, the horizontal distance traveled by the football, is 0. Because it hasn't been kicked yet. It's just at the very instant of it being kicked. So for us to find the height, we will simply sub in a d value of 0. So we go back to our equation, which was h equals negative 0.1 d minus 8.7 quantity squared plus 7.6, and we substitute 0 for d. So when we sub in 0, our equation looks like that. Then BEDMAS tells us to evaluate the bracket first, which we do. Then BEDMAS tells us next to do the exponent first, which we do. Then BEDMAS tells us to do the multiplication next, which we do. And then we do the addition at the end. And we get that the initial height of the football was 0.031 meters, or approximately 31 centimeters. Now that makes sense when you think about it, because when you punt a football, it's usually about 30 centimeters off the ground at the moment of impact. And that's what happened in this case as well. So we've now answered part A and B of that question. The next part says, part C, sketch a graph of the football's path. Well, what we do is we draw a y-axis and an x-axis, and we know that we have to put our independent variable, or in other words, the variable that's in the place where the x would normally go, along the horizontal axis. Well, in this case, that variable is d for distance in meters. And we'll increase by 5 meters at a time, and we will note our beginning height of 0.031 meters. This will be our height axis, or y-axis, because that's our dependent variable, and of course it's measured in meters as well. And we notice our initial height and our initial distance, and we notice that we get to a vertex of 8.7 and 7.6. So using a little bit of common sense, we say, well, therefore we can connect that this way, and then our parabola has to continue going the other way down to here until eventually the football hits the ground. So the football's path can actually be expressed by this parabola where the football goes up, and then once it reaches a certain distance, its height, of course, has to start to decrease where the football player on this end catches the ball. So that is a real-life example that uses a quadratic relationship. And finally, it says, what does the vertex represent in terms of the football's path? This is question D. Well, I would suggest to you that the vertex represents the maximum height achieved by the football, which is 7.6, as well as the horizontal distance required to achieve that maximum height. The horizontal distance required to achieve that is 8.7. So it actually tells you quite a bit. It tells you that once the ball's traveled 8.7 meters horizontally, it'll be 7.6 meters in the air, and then it's going to start coming down.